So again, my name is Chris Munns. I'm currently Senior Developer Advocate for Serverless at AWS. I've been here at AWS for just about 5 years now across a couple of different roles. But I actually primarily come from an operations background. So I used to do operations at places like Etsy and Meetup and a couple other places. But now I'm all about serverless. And so when we talk about what serverless is, and there's been a number of different folks who've had kind of different definitions of it today and different ways of thinking about it, we primarily talk about a serverless application existing around Lambda. So typically including the event source and then something that Lambda is talking to or touching on the other side of it. But when we're talking about a serverless application, it's basically built around AWS Lambda. And now this talk is about CI and CD, and so the other thing that I want to do is kind of set the tone for how we talk about CI and CD at AWS. So we think of development kind of having 4 phases, a source phase where you write your code, a build phase where that code is compiled, tested, linted, unit tested, and so forth, a test phase which is where you're actually testing that code potentially against other services, things like a pre-prod or a staging environment, and then production for whatever production might be for the application that you have. And so if you think about how CI and CD being ways of automating across this process, what does that look like? So continuous integration, basically the idea that as you are committing code, it is continuously being pushed through the system through at least the build phase. Continuous delivery, which typically involves the automation further past continuous integration, out through at least test, and then potentially out to production, typically with some sort of a gate, and this could be a manual gate or a logical gate. And then lastly, continuous deployment, which is kind of the holy grail of the full automation end-to-end of this process with no interventions involved. And I can say that internally at Amazon, we actually strive really, really hard for teams to get this bottom bar here. It requires a lot of work. So CI and CD for serverless also implies the fact that we also have lots of different use cases for serverless. So today at AWS, we kind of identify 6 kind of primary use cases for serverless applications. So we have web applications, backends, data processing, streaming and stuff like that, chatbots, Amazon Alexa, and then IT automation. And so each of these 6 different use cases have unique architectures to them, unique other services that they will interface with, but again, all powered by Lambda. So if we think about doing CI and CD for these 6 different use cases and workflows that we have, there's actually a lot of different options and a lot of different things that we have to take into account. And so in today's talk, I'm going to talk mostly about kind of the general broad strokes of how you can think about CI and CD for serverless applications. So as I mentioned, there's a number of different things we have to take into account. So in this model, again, with Lambda-based serverless applications, a Lambda function is a unit of deployment. We'll typically have multiples of those per application. They will each have an event trigger. There could be event trigger types that are shared between different functions. And then lastly, again, because this is not just Lambda, it's typically other services that are interfacing with it. A serverless application is going to be some combination of Lambda and those other services. My apologies for the losing of my voice on day 1 here. So what do we want to do? We at Amazon talk a lot about deployment pipelines. We have an internal deployment pipeline tool that's used pretty much by everyone at Amazon. We now have a product, which I'll talk about, called CodePipeline here today. But we want to model our CI and CD workflow across this pipeline such that as code is committed, it's going to go into a code repository. It's then going to be built exactly once per execution, where typically building, again, could be testing the code, inspecting the code, doing unit testing, doing linting, syntax checking, et cetera. From there, we'll go on to some sort of integration test where we're doing functional and then eventually end-to-end level tests. We'll want to have these then deployed to independent environments and talk about the importance of that. And then, again, have these done exactly the same way every time. So we don't want to have one deployment model for dev and then one deployment model for prod. So what are the tools that we'll need for this? So typically, some way to write our code, some place to store our code, a build tool, testing tools, deploy tools, infrastructure management tools, and ideally some sort of lifecycle automation tool for this process. The first 2, not going to touch upon it all today. So a lot of different IDEs out there, lots of different capabilities. I'm a Sublime text and VI person myself. Source control, again, lots of different options. We have a product called CodeCommit at AWS. There's GitHub, Bitbucket, and so forth. But I am going to focus here on the bottom 5. So starting here with the build section. So back at reInvent, our yearly conference that we had this past year, at the end of November, beginning of December, we launched a product called AWS CodeBuild. So CodeBuild is a completely self-managed or fully managed code building testing service that we have. It fires up environments to do the builds for you. Again, completely managed. You don't have to run any infrastructure for this. So you could think of this as a serverless build product, but we don't really define it as that. Scales up for you. You don't have to care about slots or any sort of thing like that you might with other CI tools. And you pay by the minute for the compute resources. So that's one of the kind of highlighted things that you can do with it. So if we think about how we would use CodeBuild for a serverless application, one aspect of CodeBuild is that you have a file that you typically put inside of the root directory or in the root path of your repository called a buildspec.yml file. And so I won't expect you to read this entire file. What I do want you to get from it is that there's a number of sections that are common for every build spec file that exists. So at the very top, we have the variables that are used as part of the build. So basically shell environment variables that you would pass into the build as part of execution. We then have 4 phases that are listed here. So we have install, pre-build, build, and then post-build. And essentially what you see inside of that then are commands that are executed in each of those phases. So these will happen in a sequential order here, or technically it's a hard-coded predefined order. And so we could do things like in this example of running npm install to bring in our other packages for our code, running something like ESLint to make sure that our code is valid from a linting perspective and syntactically, running our unit tests with npm test. And now at the bottom here, this AWS command I'll talk about a little bit later is a way for us to package up a serverless application. And then down at the very bottom here, we can then take this built artifact and shove that into S3 so we can do stuff with that later. So lots of different options, guys. So I mean, it's really, you can almost think of CodeBuild as a very complex shell environment execution engine with orchestration. Anything that you could run inside of a Linux host today, for the most part, you could pretty much run inside of CodeBuild. So when we think about all the different ways that we might have to test our application, again, just at the code level, this opens up the ability for you to do all sorts of different things for any of the languages that you might be writing serverless applications in. When it comes to building a deployment package, so today at AWS for Lambda, we support 4 different languages, and then sub-versions of those. So just last week, I guess it was technically, we launched Python 3. But so if you think about the 4 different languages that we support, Node.js and Python, Java, and then C#, there are different types of packages that you need to create if you're going to take that code and push it up to Lambda. And someone had made a reference earlier today in a talk to writing code in the console. I would say that if you're doing this for real, you're not writing that code in the console's text editor. Yes, we provide that with Lambda. You're typically, again, writing your code in a traditional IDE, and then as part of the deployment of that, you need to bundle that code. So with Node.js and Python, you're typically just putting it into a zip file, which you then are going to include your dependencies as part of, and all of those dependencies need to be at the root level. For Java, you can push up a zip file or a standalone jar, again, compiled with any of the class resources at the root level. Jars can be in a lib directory. And then for C#, you're also going to create a zip file, and you can use things like NuGet, or we have Visual Studio plugins to bundle that all properly up as well. So this is something you'll pretty much always want to do as part of the build phase of your application, even if your application does not need to be traditionally compiled with languages such as Node.js and Python as an example. So once we've gone through the build phase, what we really care about is how we're going to test our code. And what is it that we want to test about our code? So for developers that have, I think, a good experience in this and have a good workflow, there's a couple of things that we really want to highlight, right? So we want to make sure that our code is without syntax issues, that it meets any sort of company or team standards that we might have. So I've worked in organizations where we did have a company code syntax structure. It's actually a very useful thing. Obviously, we want to make sure that our code compiles if it's a compiled language. And then we want to make sure that it's sufficiently tested at the unit level. This is one of those areas where there's so much data that shows that unit testing pays off really, really well in terms of making sure that you have good, strong applications. But I still find it as an area that across the industry, people don't spend enough time on. So once we've kind of looked at our code, or looked at our application at the code level, what we then care about is at the next functional block size up, which is the serverless service itself. Essentially the one unique Lambda function that we might be thinking of, and then the resources that might be tied just to that. And so we want to make sure that it functions as it's supposed to in relation to its other components, has the appropriate mechanisms to handle things like failure upstream or downstream. And this is typically where you're doing some sort of mocking of the interface of that Lambda function. And so I do believe that mocking is a good and valid way for doing things. We get a lot of questions around things like testing locally, and that's definitely, I think, a pain point that we want to find a better way to help solve it for people. What it often comes down to, though, when I talk to customers about local testing, the thing is there's only so much that you could test locally. When you think about serverless applications where you have so many other hosted services that you're probably interfacing with, it's just not realistic to have that entire environment recreated on a developer laptop. And I think this is part of the paradigm shift that we're running into as developers are moving towards serverless applications, is that part of how you build them, unfortunately, involves you having to be able to connect to the services themselves. So after we've tested our individual function, our individual serverless service, as it were, then we care about our entire application and infrastructure. So this is where we're doing end-to-end testing. We're probably doing things like security testing, maybe doing some sort of automated interface testing from a security perspective, load testing, and so forth. Now, with things like Lambda and API Gateway and a number of other services, load testing really doesn't impact you the same way as it would if you were running virtual machines or even containers. And so to a degree, load testing is more just to make sure that your application and any of the other dependencies that it might be talking to, are opened up in terms of things like limits, other capacity for maybe things like databases and so forth. So again, three kind of things that we want to focus on when we're testing. We care about our code, and we care about the individual Lambda function and its related services, and then we care about the entirety of our application infrastructure. So there's a number of cool testing tools that are out there. These are some that I find myself talking about with developers pretty often. The first ones up there are code inspection and test coverage tools. If you're not using a tool to do code coverage testing, you're missing out. I find that these are tools that are incredibly valuable. I don't believe in setting hard lines like, our code must have 100% unit coverage, because it ends up leading to poorer practices around those types of tests. But still having good visibility into how much coverage you have as you're developing your code and how that changes and how that fluctuates is still pretty important. And then what we do have is another pretty awesome list of mocking and stubbing tools. And actually, the folks at Atlassian have been putting a lot of work into this tool called LocalStack, which if you hadn't had a chance to check out, you really should. And I think one of my favorite things about LocalStack that makes it such a great open source project is that it actually consumes a bunch of other open source projects. And those are my favorite kind of open source projects, are the ones that take other pieces and put them together instead of reinventing themselves. So you've got Moto, which is a Boto mocking tool. So Boto is our Python framework at AWS. And then you've got Dynalite and Kinesilite, which are DynamoDB and Kinesis testing tools that you can plug into Lambda. There's a whole lot more. Really encourage you to check out LocalStack. And then when it comes again down to the bottom here of end-to-end testing and full service testing, there's tools like RunScope and Ghost Inspector that can do things like API monitoring and testing, and then Ghost Inspector, which can do web interface testing. And so for web-based applications, it's a pretty cool tool. And I mentioned them also primarily because they have integration with CodePipeline. So that kind of covers the initial build and test aspects of the tools that we'll need. Next, how are we going to actually deploy this application? So we could go service by service, Lambda function by Lambda function, running the CLI and uploading things, or we could use a much more structured tool for doing it. And so it was actually last year at one of the serverless comps that Tim Wagner, who's speaking tomorrow, who's the GM for serverless at AWS, talked about a project that we were working on called Flourish. And now Flourish was the code name for what now is called Serverless Application Models, or SAM for short. If you've stopped by our booth or you've looked in our goodie bags, you've seen our good friend Sam here. Sam is a squirrel. Some people weren't familiar with squirrels, so squirrels are animals here that you find in the States, typically live in trees and run around your backyard and drive your dog crazy. So we've got a number of different images for Sam. We're really going to be throwing Sam out there a lot, so you'll be seeing more of this adorable little squirrel face. So what is SAM? So it is actually extension for CloudFormation that allows you to greatly simplify the writing of a template for deploying your resources in AWS. So it supports today functions, APIs, and tables, which are done via DynamoDB, APIs via API Gateway. Supports almost everything that CloudFormation supports. And you can actually interchange the two resource types for both SAM resource types and CloudFormation resource types in the same document, and it doesn't cause any problems. And this is an open specification. I'm sorry that the URL is kind of buried here at the bottom. You can find that on github.com/AWS-serverless-application-model. There's examples, there's all sorts of good stuff going on there, and I think we're really building up a pretty strong community around SAM in the GitHub repo for it. So what does the SAM template look like? This is an example right here. So this is a really basic one. I'll break down again for you here what you're seeing. So at the top, what you have, and this is what makes SAM unique from other CloudFormation templates, is that we have what's called a transform. So transforms are a feature of CloudFormation. In this case, we're calling the serverless transform, which will allow this template that is shown here to actually be transformed into a full-fledged CloudFormation template by the CloudFormation service. Then we have basically the bulk of our code right here. So we see here that this is a function, AWS serverless function. We have then the code URI where the code lives, the handler we're going to point to, the runtime, policy, and you could actually have a full policy document put into this. And then down below here where it has the event tied to it, we have a get HTML call, basically of type API. And so what this is actually going to do is create an API gateway. And then down at the very bottom, we have a table called simple table. And basically, this is going to create a DynamoDB table with the base of 5 read and write units. So this here, if we were to expand this out, actually creates a whole bunch of resources for us. So this is an example from one of the demos that we have up in GitHub today. And basically what you have is it's something like 13 lines, 14 lines maybe, that expands out to create effectively 7 different resources inside of AWS. So really greatly simplifies everything that needs to happen when it comes to provisioning the resources around your serverless application. So how do you use SAM? So you write the document, and then once you have your template created, there's 2 commands that we've added to the CLI as part of CloudFormation. The first is package, and this actually creates a deployment package or a zip file for the template itself, and then uploads this up to an S3 bucket for you and provides back a value that you could then pump into the code URI and then deploy. And so deploy is actually going to execute this CloudFormation template, or in this case, SAM template, against the backend services to create the resources that you've specified inside of it. And again, you can combine and mix and match traditional CloudFormation resources in with SAM resources. I already said this first bullet point here. Again, supports things like parameters, mappings, outputs, intrinsic functions. You can use import values, so you can do things like cross-stack references and YAML or JSON, and SAM is waving its little flag here. One other aspect that I always like to talk about for this, and so we talk about how you want to have a unified way of provisioning your infrastructure, right? Dev should look like staging or testing, which should look like prod and vice versa, where basically the actual infrastructure itself, if you were to draw it out on a whiteboard, should look the same for each of these environments, with maybe the difference being, you know, the amount of read and write units for a database or the scale of it. And then obviously with serverless applications, you're not provisioning anything, so the actual scale of things like Lambda and API Gateway you don't have to think about. And so as part of this, you want to think about how you can build a single SAM template that could be stamped out in any of the various environments that you might have, such that you don't have to have things like, this is the testing SAM template, this is the dev SAM template, this is the production one. So just something to be mindful of how you think about this. And then because it is a text document, you're going to want to store it in source control. You can actually do CI and CD of your SAM template. Often people will, as part of like a build process, you know, lint and syntax check those the same as they would if they're actual code. Cool. So when it comes to, again, reasons for why you want to do this, I like to quote, and I forget the gentleman who said this, but he said, many companies have a testing environment. Some also have a separate production environment, right? So a lot of people do a lot of testing and a lot of things that they shouldn't do in production, whereas you really want to have dedicated environments for this. One of the greatest things about serverless is that we make having lots of different environments really, really, really cheap. One of the things that I've heard over the years when I worked at AWS is, before there was serverless, is, oh, hey, keeping around all these EC2 instances for doing proper environments can get costly. I don't want to deal with that. Well, the great thing about serverless is that you don't have to worry about having all these resources basically there running, costing you money 24/7. And with Lambda and API Gateway and some of the rest of these services, you're only paying for them when you use them. So you definitely want to have a really well-structured environment mentality and methodology, I guess I would say, when it comes to thinking about how you structure your infrastructure. A number of different methodologies for thinking about how you would do this. So some people will break environments up into different accounts. You obviously want to use infrastructure as code tools like SAM and CloudFormation, make use of variables, and automating this. And I'm actually going to talk about these 4 bullet points here next. So when it comes to thinking about multiple environments, there's kind of 2 popular, real kind of main AWS kind of account strategies that go along with this. The first, which I find is really good for smaller teams, startups, typically teams of, say, development teams, that is, of like less than 50, let's say, is same account, different stacks. So this is basically having SAM pump out different stacks in the same AWS account. And I find that this is easier for the management of those resources by that team. It makes it really easy to visualize and kind of visibly understand anything from a management or monitoring tools perspective. But where you start to run into issues is where you have to really think about separating out permissions and access separation. And so if you find yourself that the team has to start thinking about that, then it lends itself more to the second structure, which is a concept of having multiple AWS accounts. So this isn't just IAM accounts inside of a single AWS account. This is actually having wholly independent AWS accounts such that all of the credentials are separate and you don't have to worry about there being any sort of crossover. So in this case, you have absolute kind of like assured separation of permissions and access. You can have resource limits that are tied per account. So this could be one way to kind of keep things from going too far in dev account versus prod account. One of the negatives, though, is that you do have the overhead of managing these multiple accounts. And so to help with this, we launched a tool called AWS Organizations, which makes it much, much easier to both create and then manage multiple AWS accounts and do kind of cross-account permissioning and things like that. One of the other things you want to think about when you're thinking about multiple environments is making use of variables. So inside of Lambda, we support environment variables. These can be encrypted or not, depending on what it is that you're putting into them. And they're available for the function basically the same as any sort of raw environment variable would be. So based on the language that you're using, you can just call them. So like with Node.js, you can use process.environment, os.environ for Python. Same things for Java and for C#. The traditional methods for pulling environment variables in those languages works just the same way. And so, again, really useful for doing things that need to be unique per environment, whether these be pointing at other services or other endpoints, whether this be actual credentials to things like databases. There's a lot of different options that you have here. API Gateway also has a concept of what we call stage variables. And so typically, though, in a SAM environment, you're not creating multiple stages as part of the same API gateway, insofar as you're typically creating individual API gateways per environment. But you can use stage variables to pass in kind of unique aspects about your API, and they'll kind of get passed on straight through down to the function call as well. So they can live in kind of either place. So examples of what this looks like in SAM. So what we have here is a parameter over on the far left called my environment. We also have one called special feature 1. And then what we have is the Lambda function resource, and then the serverless API gateway endpoint resource, and just basically showing you what it looks like to include these. So when we go to launch this this SAM template, basically we can pass in then as parameters these 2 values, which will then get passed into the underlying services themselves. So for example, thinking of special feature 1, this could be a feature flag that we toggle off or on depending on the environment that we're in, and for the term my environment, maybe we do some introspection in our application and we use that for some sort of A/B division inside of our application. Excuse me. Cool. Another option that we have is one that people I don't think know much about yet. Another thing that we launched at re:Invent just a couple months ago, which is a service of ours called Parameter Store. And so Parameter Store, much like the name might imply, is a parameter store. And so with Parameter Store, you have basically a centralized service that you can query for getting information from, which are these parameters. And so these can be encrypted. You have IAM control around them. The access to them is logged with CloudTrail. And so in situations where maybe you don't want to share out keys into, say, a SAM template directly, you don't want to have them embedded directly into the application, obviously, Parameter Store is a really great option for these. And so in your code, basically, you can just call out to Parameter Store to include, or to basically pull in the value that you need, and then use that inside of your code. So you do have to pay a little bit of the penalty for calling out to that information and pulling it back in. But for resources and credentials and things that you want to keep centralized, I think this is probably the best option out there. Awesome. So we talked about environments, we talked about variables, and we talked about, again, some of the other options for getting things out there. Now let's put it all together and kind of automate this process. And so for this, we have a service called AWS CodePipeline. This is based off of an internal tool that we use inside of Amazon called Pipelines. Unique naming here. And basically, this is a continuous delivery tool. So it allows you to automate from check-in all the way out to production with as many different, what we call, stages inside of that as you might need, with as many different actions inside of those stages as you might need, including things like manual actions. And this actually provides a capability for you to integrate with other tools. So there is there's an ecosystem of third-party tools and AWS tools that exists. You can actually trigger Lambda events from inside of CodePipeline. And so it gives you a lot of options for things that you can do as part of it. This is just kind of like a visualization of this. So it is a visualized service that shows you as an execution is happening what the flow is of what's going on. And so if we want to think of a really basic kind of pipeline flow, we would commit our code. And so CodePipeline is going to be looking for changes to our code. We're going to package, test, and build that in CodeBuild. From here, then, we'd want to use something like CloudFormation to deploy a SAM template to deploy our Lambda functions and our Lambda code. Maybe we want to make use of something called change sets, which allows you basically to do effectively a dry run to see what's going to happen or what's going to change. Then we can make use of specific stage or environment parameters passed in via CodePipeline. I'll show you an example of this. And then we obviously want to test our application between stages and environments, depending on what stage we're in, depending on what kind of testing we need to do. So, a really basic developer environment pipeline might look something like this, which is basically what I just described. We've got our source stage, we have our build stage, and then we have a deploy to a single environment. And then down at the bottom, we're going to call out to Lambda to run some, stubbed end-to-end service test, perhaps. And so this could be the kind of thing that every developer in an organization has, where the source stage is pointing to their branch, and then at some point we merge this into master. In talking about how we get variables into SAM templates from CodePipeline, we actually provide two different methodologies for you. One is you can actually reference a file inside of your code repository. So this is kind of a way to continue to treat these as code inside of it. The other is via what we call parameter overrides, where these are actually put into CodePipeline, and then CodePipeline injects this information at execution time. So pros for the first over here on your left is, this allows developers then to own these variables so they can control what's going on with them, what they have, what they are. So it can be really easy to iterate then based on a deployment. Potential cons, again, is that it's a little harder to control security or confidential information. And you run the risk of having to think about how you check that file for accuracy as well. And then with the parameter overrides, you get slightly tighter control over what gets passed in, and you can actually also restrict the access to who can edit this in CodePipeline, view it, and so forth. So you could have kind of a level of access control greater than if you were putting it into a parameter file. However, I still feel that parameter store is probably the better way to do this for truly, secure, confidential information. And then one con to this, though, is that it requires you changing the pipeline, which you can't do mid-execution. So you would have to wait for your execution to stop, and then edit it, and then cause another execution to happen. So 2 different models inside of CodePipeline to pass in environment unique specific variables. So we took the dev pipeline, and basically now we're building onto it 2 more stages for the rest of what we consider maybe a very simple, in my mind, production pipeline. In this case, we've added 2 other stages. We have a deploy stage, and then we have a deploy prod stage. And again, making use of CloudFormation, making use of third parties to test our application as it goes through this. Cool. So everything I just showed is actually, last week we launched a product called CodeStar. It actually combines for you code commit, code build, code pipeline. It comes with a number of pre-built in, we call templates for applications, including serverless applications. So I'm going to really, really quickly run through that, but I want to be mindful of the time. Cool. So I have a really basic Lambda demo here, and actually let me just show you kind of what it looks like to create a new project. So we can create a new project inside of this, saying that we want to use Lambda as the core, basically compute technology for it. We've got a number of these predefined templates for some of the more popular languages and frameworks that we see. And then what this is going to do, after I were to go and create this, which I'm just not going to go through right now, is it's going to give me a code repository. It's going to give me a code build configuration. It's going to set up deployment mechanisms via CloudFormation, and it's going to set up a pipeline for me. And I can see basically visualized inside of this commits that happen. I don't have a running application in here right now, but if I did, I'd have the ability to show various different CloudWatch metrics inside of this. I could see if my pipeline's being executed. So as the members of my team are going and developing through this, they could very easily, I could come in and see exactly what it is that's going on for the shared pipeline that's part of this. The other thing is that we give you the ability to set up what we call a team. Pretty straightforward. It basically gives you the way to create like a group of IAM users inside of this, inside of CodeStar, and it automatically gives them access and the right permissions to all of the various services that are part of this. And so it becomes really, really easy to glue all of these things together. Really encourage you to check it out. Again, it just launched last week, called CodeStar. It's in a number of regions right now, so Virginia, Ohio, Oregon, and then Ireland. And it's pretty cool. And it makes it really easy to get started with a kind of, again, full-fledged CI/CD stack for serverless applications. And actually, one thing that it does is it gives you a default repo that has both a build spec file that's really, really basic, and then it also gives you a template file for SAM. 50 seconds. The bomb's going to explode. Cool. Last thing I want to talk about is a couple of months ago, we actually launched a landing page for serverless and all the resources that we have at AWS for serverless. So you can find that at awsamazon.com/serverless. Our reference architectures, code samples, lots of different things are linked off in this, so we're going to keep building up more and more content on this. Again, you can read more about kind of everything that I talked about here today. So SAM is out in GitHub, Lambda and API Gateway, I'm sure you know where to find those things, and then CloudFormation, CodePipeline, and CodeBuild, and CodeStar, which I don't have up there, also easy to find. With that, I'm not going to take questions from the stage, but I will be back at our booth over in the 10 area, so feel free to swing on by. We have Lambda developers here this week. We have solutions architects. We've got myself as a developer advocate. We've got all sorts of folks, and so we'd really like to talk to you more about serverless. And feel free to come grab some SAM stickers. It's a fun little furry friend. So thank you all, and have a great rest of your week.